All right, so we're going to do number 14 from chapter 2 in the physics textbook. It reads, and this is a calculus question, tells us right there, it says, a race car starts from rest and travels east along a straight and level track. For the first 5 seconds of the car's motion, the eastward component of the car's velocity is given by Vx of t is equal to 0.86 miles per second cubed times t squared. And then it says, what is the acceleration of the car when Vx is equal to 12 meters per second? This question was a little bit confusing for me since, the velocity function has meters, or it has, meters per second squared, because that's an acceleration function, but I don't know, I figured it out. Usually when you have those types of things in these functions, you just gotta learn to ignore it in a way. So, because it's just an amount, it's just a number that you're working with. So it doesn't matter. It does, but so we know that Vx of t is equal to 0.860 meters per second squared. Is it cubed? Yeah, it's meters per second cubed. This is jerk, actually. This is not acceleration. Okay, and then t squared. Okay, and then we're trying to find it when Vx is equal to 12 meters per second. So, we can so what we're trying to find out is the acceleration of the car. Now, to find acceleration from a velocity function, we're going to need to differentiate. So that can be done pretty easily. So ddt of this function, you can rewrite this function as 0.86 t squared. And then it's really easy for mathematicians because this just looks like a bunch of garbage, and when you rewrite it like this, it just makes it so much easier, because you shouldn't, putting units inside of an equation is stupid, I think. But that's just me. I'm a freshman in college, don't judge me. But I think that it is. That's how it is. So this is our velocity function. To find the acceleration, we're going to need to do the power rule, and so it's like, just multiply this by 2, you end up with, I just want to make sure I'm doing this right, 1.72 t. So this is our ax of t. This is our acceleration, 1.72 t. Now that we have that, that's important to have, but we need to find out, so it's asking what the acceleration of the car is going to be when the velocity is 12 meters per second. So we need to find out when that's going to happen, because we can't plug that t into our acceleration function unless we have it. So now we need to figure out when 12 is equal to this one right here, so 0.86 t squared. And so then you can divide by 0.86 on both sides. And then, so you got t squared is equal to 12 over 0.86. And then, squared, so you're going to square root it, and you end up with t is equal to the square root of 12 over 0.86. And now we can plug that into a calculator, and what it's going to give you is, so this equation, this t is the time when the velocity is equal to 12 meters per second. Just to clarify, so t is equal to 3.7354 seconds. So now we can plug that into our acceleration function. So 1.72 times 3.7354, and then that is going to give you your acceleration, which, let me make sure I'm doing this right. Yeah, that's going to give you an acceleration of 6.42495 meters per second squared. So that is the acceleration of this race car. I believe that we're talking about a race car. Yes, we are. A race car. This is the acceleration of it when at 3.7354 seconds, which is when the velocity of this car is at 12 meters per second. So yeah, and if I added too many numbers on this, I don't know, I like to do that, keep it a little more exact.